Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter motion in a straight line. So any doubts if you have, then please write that in the comment section. We shall obviously clarify them in the subsequent videos. And in any other chapter of physics, if you feel more difficulty, then also mention the name of that chapter in the comment section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. For so here it is told in the first question that for a body moving along a straight line, the following VT graph is obtained. According to the graph, the displacement during uniform acceleration is greater than that of uniform motion. So here we know that displacement is the area under the VT graph. Displacement is the area under the velocity time graph. So here, as you can see in this graph, the area of this this first part, it means that when there is acceleration, so here the area is lesser than the rectangular part, means when velocity is constant. It means when there is uniform motion. So it means the uh, displacement, the displacement during uniform acceleration is obviously lesser than the displacement in the uniform motion. Since why the graph of the rectangular part is slightly more than the area of the graph under this trapezium. So it means option B is the correct answer, that the displacement during uniform acceleration is less than that during uniform motion. Then it is told particle starts from rest, its acceleration a versus time t is shown in the figure. The maximum speed of the particle will be. So here it is the acceleration versus time graph. So we know that change in velocity is the area under acceleration time graph. We know that the area under the AT graph, area under acceleration time graph would be equal to the change in velocity. Change in velocity. So therefore, area under the acceleration time graph, we can say it is half base into height, half into 10 into 8, that is equal to V minus U. Here, here it is told the particle starts from rest, so U will become 0. So the maximum velocity will be equal to half into 10 into 8, so 40 meter per second. So option B is the correct answer. Then it is told the displacement x in meter of a particle having mass m moving in one dimension under the action of a force is related to time t by t is equal to root over x plus 3. The displacement of the particle when its velocity is 0 will be. So here we can see that root x will be equal to t minus 3. So therefore x, I can write x will be equal to t minus 3 whole square. And x should be greater than 0 also. X will be obviously greater than 0. And so t should be always greater than 3. T should be always greater than or equal to 3. The displacement of the particle when the velocity is 0. So it means dx by dt will be 0. We have to find the displacement x. X we have to find when dx by dt is 0. So dx by dt from here we can find that is 2 into t minus 3 into dt by dt, which is 1. So, therefore we can see that at t is equal to 3 second, velocity is 0. So therefore x will be equal to 3 minus 3, that is also 0 meter. So option D is the correct answer. It means when the velocity is 0, then the displacement of the particle will be 0 also. Then here it is told body is moving along a straight line with an initial velocity v naught. Its acceleration a is constant. After t seconds, the velocity becomes v. The average velocity of the particle over the given time interval is. So we have to find the average velocity of the particle. Average velocity. So we know that average velocity, that is equal to total displacement by time. The total displacement by time interval. So now S we can also write v square minus v naught square by 2a. Since we know v square equal to u square plus 2as. So since initial velocity is v naught and final velocity is v after time t. So after time t, the velocity will be v. So the displacement will be s equal to v square minus v naught square by 2a, where a is the uniform acceleration of the body. So s we can write it as, so it will be v square minus v naught square by 280. So it means option B is the correct answer. And then here it is told a balloon is rising vertically. A balloon is there, it rises vertically upwards with a velocity u, which is 29 meter per second. A stone is dropped from it. So a stone is being dropped from it and it reaches the ground in 10 seconds. The height of the balloon when the stone was dropped from it is, the height of the balloon when the stone was dropped from it. So when the stone was dropped, then the height of the balloon was how much? So it means that the stone was dropped from how much height? That is being asked. So now, if we take acceleration due to gravity, that is downwards, that is 9.8 meter per second square. And suppose we take vertically downwards as my positive direction of x-axis and up, so then vertically upwards will be the negative direction of x-axis. So therefore we can say reaches the ground, so in 10 seconds, so t is equal to 10 seconds. So I can say s is equal to ut plus half at square. Now the displacement of the ball, the displacement of the stone is h, which is vertically downwards, and u is minus 29 into t, that is 10, then plus half g is plus 9.8 into t square. T is 10, so 10 square. It will be minus 290 plus this will be 2 4 is 8, 2 9 is 18, so 4.9 into 100, so this is plus 490. 490 minus 290, so that is 200 meters. So it means the balloon was being dropped, the stone was being dropped from a height of 200 meters above the ground. And so at the time when the stone was dropped, the height of the Balloon was also the same, which was 200 meters. So option 2 is the correct answer. So hope all of you have understood the solutions of these questions on the previous year KCET exam. But still, any doubts if you have, then feel free to write us in the comments section. Mm, and also please install our Sapience education application, since we shall upload some important homework questions based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone.